Guys and girls, it's Know It Time!
Alright, so today, before I start today's lesson, you need to know a bit of review. And this goes back to what I did last chapter with you. It is, which is on combinatorics. We're reviewing combinatorics. And I'm going to give you a question as a review. Draw 3 cards. How many ways can you get 2 hearts? Good luck. I'm going to pause it. Abraham, you have an answer? Sorry?
Are there 3 cases for it?
3 cases? No. Only 1 case. Think about why is only 1 case. Well, see, in order for you to know how to do this, you need to know how to do combinations. I mentioned to you many times before, when you deal with cards, combinations, all that is combinations question, and that's based on something called NCR, which equals to, here's where you come in. Eeny, meeny, miny, mo. Aaron, well, what is it going to be? Nope, show me the work. 13C2, yep. No. Times 39C1. You have to know to be really good with this. If you can't get this, you're going to die in the next unit. Try this one. 5 cards. Again, same concept. I want exactly 3 queens. Exactly 3 queens. Show. Again, exactly nothing hard. Again, I don't need the answer. I just need the work. Because work means everything here. Gary, take a guess. What is it? 4C3 is correct. Yep. Times 48C2. That's it. See? I don't need to see the answer. I just need to see if you can understand how to do this. Next one. At least 1 queen. 5 cards. I'm going to pause it. At least 1 queen. Here, there's at least statements. So you have to have cases. In this case, you have, how many cases are there?
1 queen, 2 queen, 3 queen.
1 queen, 2 queen, 3 queen, and? So you have 4 cases.
Can you have 4 queens?
You can have 4 queens, yeah.
So these 2.
So you have 4 cases. So you go 4C1, 48C2, plus, oh, you can't have 5 queens. Not a rigged card.
We were playing a card game and I said that all the time.
4C2, 48, whoa, sorry, not 48C2, what am I talking about? 48C4. 4C2, 48C, plus so on, so on, so on. You should get the idea.
48C,
Okay. You should get the idea from 4 cases. Easy stuff. I'm going to mix it up. Now, back to my notes before. A lot of you asked me to know, when do we use combinations versus permutations? And I give you a general idea. Combinations, remember, work with all card questions. All card questions. Anytime there's a card question, pretty darn good chance you need combinations. Another one is group questions. Group questions.
Is it NCR?
Yep, NCR. And this is example boy-girl stuff. Boy-girl. The classic one. Give you another question and see if you can do this. In a class, you have 5 boys and 4 girls. Pretty small class.
Some village,
Some village in India where the population is.
There's only like 300 kids in class.
Here is your question. I want to know how many ways. Again, how many ways can you choose? You choose a group of 3 people where the majority are girls. Majority are girls.
Why girls?
Makes no difference. Even better. See, here we have case 1. The key word is majority, so which means you can have 2 girls. Or you can have case 2. You can have 3 girls. That's it. And I'm going to quickly do so. This is 4C2 times 5C1. 4C3. That's it. 5C0, which we don't really need. Now you can have case 1 or you have case 2. So we know we're going to add together. So you're going to add these 2 together. Voila. See, that was a review. Here is your lesson, true lesson for today.
What? I wrote true lesson like 6 times today.
No, I see. Didn't you say? I see the word review. Review. Combinatorics. This is why you need to know this stuff. Today, I'm going to teach you something called combination plus. You're going to mix it together with P. Probability. Probability. Together, I call this combinality. It's a word I made up. I patented this word, combinality. Today, I'm going to teach you something called combinality. It's a combination. You're mixing combination and probability together. See, combinations is easy. It's just what you just did last chapter. Probability, you got to remember the star. The formula for probability equals to desired outcome over total outcome. See, a lot of people don't know the difference between probability and combination. Combination is how many ways. Probability is the formula for desired over total. Another thing, your P cannot be greater than 1. It's the law. Greater than 1. If you have an answer of 2.6 as your probability, it's wrong right off the bat. I don't even have to look at your work. Because your probability cannot exceed 100%, or in this case, it's just 1. Combinations, really, your number can be anything you want. Thousands, millions, it doesn't matter. I'm going to give you a question now. Draw 3 cards. Find the probability. Notice I'm using probability. I'm not asking you how many ways anymore. Probability of getting 3 hearts.
You've been asking us this the whole time, right?
No. Look what I asked you before. Before,
Not in combinatorics, like before in probability. Like what you've been learning.
sort of. See, before I asked you how many ways can you get 2 hearts. This time, I'm asking you different. What's the probability of getting 3 hearts?
What's replacement with that?
Always without, when you deal with cards, unless otherwise stated. Right off the bat, I'm dealing with a card question, so you know you got to use NCR.
1300?
Somehow it involves NCR. Because when you deal with cards, it's always based on NCR. Find out how many ways can you get 3 hearts right now using NCR. And I need an answer for this time. 3 hearts. 286? How do you get that? You went 13C3, which is 3 hearts, so it's 286. If my math is correct, let me just calculate. 13 factorial over that. Yeah, it's correct. 286. See, this is 286 ways. I know this can't be my probability because it's bigger than 1. Probability, this is called my desired outcome. Desired outcome. There's 260 ways. But now, I'm going to divide this by something. Sorry. So now, you have 13C3 on top. But, you're missing something on the bottom.
Your total outcomes.
Which is 52C3. And this is your total outcomes. Because there's 52C3 different ways of choosing cards. This is your total outcome. Yep, you're choosing 3 from 52. So that's why you got 52C3. 286 divided by 52C3. Punch in your calculator right now. Which 2000. What? Wait, say again slowly. 22100. Punch in your calculator. 286 divided by 22100. 0.0129. See, look, this is my answer now. Look, my answer is smaller than 1. This is called probability answer. In other words, it's roughly 1.2 or 0.3%. If I were to draw 3 cards, the probability of getting all hearts is 1.3%. Hi. You can leave it here or here, it doesn't matter to me. Guys, try this now. You get the idea of how this is the difference between probability and combinatorics. If you can't do combinatorics, you can't do this unit. Try this one. Draw 5 cards. What's the probability now? I get exactly 2 jacks.
I'm right. Gosh,
We'll find out you're right or wrong. So, right off the bat, 2 jacks. 4C2 times. Oh, there. Because, how many cards were I using up there? 3. Times 48C3. But we're not done yet. See, if I stop right there, what I'm getting is something called combinations. But I'm looking for probability, so I got to divide this by something. 52C5. Because that's the total number of ways of drawing 5 cards from a deck. 52C5. And a lot of you are going to have trouble and say, Mr. Where did this came from? I'm drawing 5 cards. Okay. Jacks? Just jacks, yep. There are 5 cards, yep. No, there's 5 ways. There's 52C5 ways of choosing 5 random cards from the deck. Yep, that's where the top part is. Nope, the bottom is the total way of selecting things. And punch in your calculator and you get your answer, whatever that is. 4%? Roughly. If your math is correct, I should have around 4%. So in other words, if I was to draw 5 cards from a deck, there's a 4% chance I get 2 jacks. Try this one. P at least 1 ace.
How many cards?
See, at least 1. I've taught you a technique how to do at least 1. If you don't use the shortcut technique, you have 4 cases. Too long. See, at least 1 really refers to 1 minus P none. P none refers to no aces. If you don't have an ace, would you agree just 48C5 over 52C5? That's it. Figure that out right now on your calculator. And then 1 minus that. See how easy that was? See how Now, if you didn't use this shortcut technique, you would have 4 cases and it takes too long. And that's your answer. 1 minus 48C5 over 52C5. Well, whatever it is. I'm going to pause it. Try this for me, please. Nope, not yet.
What?
You're not ready for it.
We are so ready.
Oh, please. A bag contains 6 blue marbles, 10 yellow, now here's your question. 2 marbles are drawn. Without replacement. Are drawn without replacement. I'm going to ask you a few questions. Number 1. P both blue. Okay, very simple question. There's no tricks to this one. P both same color. I'm going to pause it. See, there's 2 ways of doing this. One, you can try to use combinatorics and say, hey, look, order doesn't matter. So I can go 6C2 divided by 16C2. But I'm going to teach you this the simpler way. Write this down for me, star.
Simple than that.
Yep. If you are only drawing 2 items, use a bracket method. It's a lot simpler. Bracket method. Because there's only 2 methods. One is you use NCR or you use a bracket method. I'm going to show you why the bracket method is a bit easier to understand. I'm going to draw 2 marbles.
Oh, could they just be?
What's the probability of first is blue? 6 out of 16.
That sounds 5 out of 15.
5 out of 15. So easy that was to understand? Because there's only 2. Because those are only combinations that can have. Now, but if I draw 3 or more, then you have to use NCR. It takes into account all the other factors. What about this one? Both of the same color. I'm going to pause it. See, in this one, I didn't mention the color. If I don't mention the color, guys and gals, you can choose any color you like. So you can have case 1. If case 1, both blue. C1. Both blue, which is what you found already. Both blue. Which is 6 over 16 times 5 over 15. Or I can have case 2, which is both yellow. Which becomes 10 over 16 times 9 over 15. See, if I'm drawing only 2, I use a bracket method. Very simple. If I do 3 or more, you have to use NCR. Here is your super no question for today. Good luck. Team challenge. And this is my last question for today. Then after that, you should be able to do your homework.
Group challenge?
Yep. A jar contains 40 marbles. Equal number. Sorry, I'll make it easier for you. 32. It's just slightly easy. Equal numbers of red, blue, green, and yellow. 5 marbles are chosen. Without replacement, as always. Chosen. Your question is this. Probability, all 5 of the same color. Good luck. What I'm looking for is your work. Now, let me show you how to do this. See, I never mentioned any color. I just said same color. So in theory, how many cases could you have?
You have one.
Whoa, 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 whoa,
Each
whoa.
color is the same.
Whoa, whoa,
Same
whoa.
number of each color.
Whoa, how many cases can you have?
Okay, fine.
4. In theory, you can have 4 cases. Because I don't know what color it is. Let's start with red. So probability choosing 5 reds then. Agree? Which would you agree then is going to be 8C5 over
32C5.
32C5. That's assuming it's red. I don't know it's red. I'm just assuming. I could have also assumed it could be another color. Okay, I can assume case 2. What color could I assume? Blue.
Green.
If it's blue, what's the formula going to be?
Same thing.
Exact same thing. 32C5. I'm just assuming.
You just multiply that by 5.
Oh, whoa, whoa, not yet. I could assume case 3,
Green. Green.
which is green.
Yellow.
And would you agree it's the exact same thing? 8C5. Or I can assume exact same, which is yellow, which is 8C5. It could be any one of these cases, agree? Any one of these cases. So guess what I'm going to do? Add them.
Oh.
Add. You can add all 4 cases together. Or some of you say, hey, Mr. Snow, they're really all the same thing. So can I just go 4 times 8C5 over 32C5? Or some of you say, hey, look, well, there's 4 colors. So I go 4C1. I choose a random color first.
What the heck?
And then I go 8C5. No matter what way you work, you always get the same answer, which is 0.001. Not 0.13.
0.01%. That's what I got.
Okay. So guys, gals, many ways of doing this. You can either, whoa, please. So you can do this format, or you can do the super long way.
Yeah, we got the percent.
Okay, give me a sec. So guys, gals, your work. Page 123. You need a lot of practice on this one. Because if you don't practice, I'm going to tell you, this stuff is going to be tough for you. Numero 3 to 20. Whoa, 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 whoa. Jeez Louise.